minus pi over 4, and this guy is plus pi over 4. Okay? Halfway in between those 2 points, your function is going to go through a 0. Going to go through a 0. Then let's go take a look at the mother again so we can remind ourselves of what it looks like. It's going from down and going up. You guys with me on that? Okay, so again, you need to know your mother before you can do anything. Halfway between 0 and minus pi over 4 is what point? Negative pi over 8. At that point, the graph is going to go through minus 1. So this is minus 1 here. Okay. Now, had it been 3 tangent 2x, this point would not be minus 1. It would be minus 3. Okay, everybody with me on that? Okay. Halfway between 0 and pi over 4 is your point pi over 8, and it's going to go through 1. So here's your positive 1 here. Okay. And your graph goes from this point like this and goes up to asymptote out here. You guys with me on this? All right? Everybody get graphing tangent? So graphing tangent in some ways is easier, but it's just that the boundaries really come from minus 2 and plus pi over 2. Tangent is even different, so you need to go look at YouTube and take a look at the how the cotangent is different. Okay, look at YouTube and see how cotangent is done. Okay, it goes from 0 to pi. Okay, so there are all these little details that you've got to know. Okay, no two ways about it. Okay, is everybody all right on this? Pi over b, b is equal to 2, so in this case it is pi over 2. Amplitude, there is no amplitude for tangent. Not applicable, because tangent's not going between 2 values. Okay, it's not like it's going in plus or minus 3 or plus or minus 5. Okay, tangent goes on and on and on and on and on and on. It never bounces back and forth. Okay, so amplitude, there is no concept in the tangent. Phase shift in this particular problem, 0, because you would say 2x equals 0. X would be 0, so phase shift is 0. Domain is a good question now. Okay, it's a good question. If you take a look at your tangent, remember we only drew one period of tangent, right? It repeats itself over and over and over again, right? So at the asymptotes, you can't have x values, right? Right? You cannot include the x values where you have an asymptote. So your first asymptote is at pi over 4. Okay, well, I'm starting from the right of 0. Okay, so pi over 4, where is the next one? Sorry? Where's the next? Sorry? Okay, how? Why? Nathan. Why do you add pi over 2? Fantastic. Awesome. Everybody with him on that? Okay, so the next one is at 3 pi over 4. Where's the next one? 5 pi over 4. Where's the next one? You guys get a pattern here. So, domain is all real numbers except, not all multiples, but odd multiples of pi over 4. Is everybody with me on that? Okay? Alright, you cannot include the asymptotes as part of the domain. So the domain is every number except odd multiples of pi over 4. You with me on that? How do you write? You can write it in English like that. I'm okay with it. So, all real numbers except odd multiples of pi over 4. Okay? Anybody want to write it mathematically? Does anybody want to see how it's written mathematically? Okay, this is the way you write it mathematically. Okay? You can say all real numbers if you want like that. Okay? Except odd. 2n plus 1 is an odd number. Always guaranteed if n is an integer. That's always an odd number. And you can put a plus or minus here because then you've got minus pi over 4, minus 3 pi over 4, minus 5 pi over 4, and so on. Is everybody with me on that? Okay. Sorry? All what? Well, it'll depend, right? I mean, if you have a phase shift, then things are going to change and so on. I'll tell you that on 4.5 through 4.8 tests, the tangent and cotangent will not be graphing with a phase shift. The sine and cosine will be. Notice that your test is 4, 5 all over again. Okay, and the reason is that in the previous 4 or 5 there was no phase shift. Okay, the one on Friday again is going to have a phase shift for sine and cosine. Okay. All right, you guys okay so far? All right, I want to move on to 4.7 now. So 4.7 is about inverse trig functions, okay? Inverse trig functions. So before we do that, we need to know what an inverse is. What does an inverse mean to you? You've been there, done that. What does an inverse mean? Yeah, Ma? Yeah, but what does it mean? What does it mean? Sorry? What do you mean by reverse? Can you be a little bit more mathematical on that? No, exactly not. Exactly not. Yeah, exactly not. So please make sure you don't make this mistake, okay? F inverse is not 1 over F. Okay, it's not 1 over F. So please do not make that mistake. Okay, do not make that mistake. Yeah, Ashwarya. What do you mean I put into? Can you use mathematical terms for me? What's that mathematical process called? Sorry? Yeah. Okay. What is it called? Yes, you're right. When you do fog, except it won't be fog. Yeah, I mean, I get your point. What's it called? What's the technical term? Starts with a C. Give me an O. Give me an M. Give me a P. Computard. Yes, I agree. You be computards. Give me an O. Thank you. Function composition. Function composition. So, Ashwarya, instead of doing fog, you'd be doing this, and this had better give you an X. That's what technically an inverse means, okay? So that's the definition of an inverse, okay? And obviously it's got to be the other way as well, okay? It's got to be the other way as well. Okay, let's take a look at trig functions, okay?